Good morning, everyone. Thanks for your introduction, Sam. I'm Weijia Xu. I work at the Texas Advanced Computing Centers, and I'm very happy to be here today and talk about our project on the good system for smart cities. And for this project, it's coded by Dr. Junfeng Jiao, me, and Dr. Nak Chuan from the Department of Mathematics. And we are also joined and tap into the expertise of a variety of faculties and in the different domains, like Dr. Min Zhang from School of Architectures, and so on. So for today's presentations, I will give an overview about what's the project about and what's our latest progress after the first years. I think it's a very interesting field, and it involves a lot of the different peoples from different domain science and require different expertise to work to contributing to these fields in general. So specifically for our project, we realizing it is not a single kind of domain science like we used to have, and then one of the main challenge be able to bring all the people and all the stakeholders together is to connecting them, not connecting people, but also connecting different data set together and connecting data to model, then connecting model to the decision makers or whoever going to be impacted. So that's going to be the main kind of motivation for this project, is to be able to build such a system that can smartly connecting data together, connecting data to appropriate model, and connecting the model decision, inform that to the decision makers there. The key research question we're going to tackle in this project, including first is how we can fuse and link the different data sets to form the foundation of such a system, right? So we don't want to building a application for one use case only. We really want to looking for a better scalable way, be able to fuse different data sets together that can serve a variety of the use case we're going to tackle, from smaller one and to the bigger ones. So the second main question we want to tackle is, can such system be used to predict the undesirable social economic impacts of new urban development and provide a tailored intervention strategies? So this question actually comes from a very ongoing situation with the city of Austin. For many of you aware, like last year, city approved the new Project Connected Development, and which is multi-billion over like 20 years developments to build a new light rail system. So how that's one going to impact the local communities, not just the Greater Austin area, but more for where the line going through and how they to benefit or bring any other adversary impact to that is a real question, and nobody really have the answer to it. So one of the ideas for this project is built to trying to finding a solution, or at least trying to building up tools and trying to help to answer that questions there. Then we want to generalize those what we learn and what we have. And to the third question is how well the system can predict the future impacts to a local neighborhood. So we want to build a foundation to connect data and to be able to do that and testing that with the Project Connected developments. And then we want the system can be further extended and for similar project in the futures. So to do so, the entire project will consist like three big pieces. One is we want to design such an AI framework that help us to fuse the different data sets and within the cities and across the cities. This is very important, not only like to be able to connecting data set not from your current cities as well. So for example, for the Project Connect, such like for us to do the machine learning, we're always trying to learn from the past data, right? But like for things like a Project Connect is something never happened before. So where we can learn from that example, how we can build a model, how we can developing that. So that's require us has to looking for example on the data elsewhere. Like say we don't have the light rail before or such light rail, large scale light rail system before, but other cities like Seattle, like San Francisco, they had such similar system before. So we want to be able to tap into those. But then the question is how you can transfer that knowledge and how you can transfer what we have from a different region, different time, and to now and to another regions. So we want to have that basic framework, and we want to be able to using machine learning and AI be able to extracting and presenting information here. So that's another aspect about the smart city, about data in general, is we don't want to just say blindly grabbing all the data together and put them into the one pool. And right now, like we are really in a state what we call the information overload, because you can easily get in so many data and you have to go through them and find out what's important. So just grabbing the data together is less useful than really. We also need to help to go through data, be able to extracting what's important, what's really relevant here. And then, so that's two core ideas, and then we want to, once we build the systems, we do want to evaluate them with a concurrent real-world development project, and in this case, it's going to be the Project Connect. So for the project, the methodology is really spans different domain of fields. And then the first one is we're going to use machine learning to automatically merging on the different smart city data set based on the given objective. So this is more, the first foundational step is how we can developing tools, be able to grabbing the data and putting them into one pools. And then we want to use the graph theory and deep learning to be able to mapping those isolated sets together to form a knowledge network. So this is going to be different than currently we go to Google, we type a keyword when we're trying to search something, and this will be more like a kind of the search engine for the data, but it's also help you to know what are the relevant data, so you don't have to know, I have to know the name for the data set, be able to get it. And the idea is we want to say, I want to get in all the data relevant to the fire, or I want to get in all the data relevant to the traffic. It can help you to bring that to you, and then maybe even more smarter on given a question, they can give you, this might be the data set that relevant to you. And then we want to really linking those data to the existing academic work on different urban planning models to see what are the needs and what kind of questions it can really help quantify. So the system will not connecting the data together, but the data to the models and model requirements and their output. And then once we have the output, we can go and type into the domain-specific knowledge and expertise from different domains and to see whether the model output really be useful and resolve any real practical problems in the different domains, such as transportation, environment, and housing issues. And then the last, but it's also very important part, is we can do the machine learning for individual problems with the individual data set and do the individual prediction, but ultimately, we also need to translate that prediction results back to decision makers, and it helps them to understanding what's the impact and helps to be able to really make the real life change. So we want to use the economic public policy and the city staff experience to help us to evaluate the social and economic impacts of smart cities and the use and funding, the making the policy recommendations as well. So for the entire project, and we have been designed as a 3-phase project over the multiple years. And for the 4th and 5th years, we're going to focus on project concurrent developments and trying to evaluating what's the impact the Project Connect project will bring, and then we want to be able to extend it and scale them out. Then the first 3 years is really like the key research development phase for us. And on here, we want to be able to go through the steps I was just saying. Is on the first years, we're focusing on bringing data together. On the second years, we're going to focus on bringing data and model together. And on the third years, we're going to focusing more on how we can do the knowledge transfers and between different use case between different regions and help that to turn into a final system so we can use it for the Project Connect assessment later on. So for the first years, and we're specifically has been targeting into the challenge and the preliminary implementation to solving the data collection issues and the data fusion modeling and those use cases. So I will go, in the next couple of slides, I will quickly go through like what we have been doing. So first is the data collection part. As I was saying, like for the smart city, it is a requirement for us to getting the data across different domains and across different time and across different regions. So we have this diversity of the data in 3 dimensions: the information dimension, temporal, and the spatial dimensions. we need even for like a time dimension. So we're not going to just getting what's a historical data, like say last year what happened, the 10 years before what's happened. We're also talking about real-time streaming data from different sensors. So it really matters now, right? So we can build the models from 10 years ago, but we also need to know how that one can be used for current data. And eventually we are going to connecting the data to the model, so the model will also give you the future data points on what will happen in the next hour, what happens in the next day, right? So that's makes the things that's really interesting is we're not only talking about getting the past data, but the current and the future prediction data as well. We do need the data across different regions and the geographic scale. So we have the things like point-specific data that's coming from the sensors, and we also have a community-level data from like local community generating or user generating data, and those can give us more localized informations about the neighborhoods. And we also have an even larger scale, and like the data from sensors, where it can give you annual or quarterly status for the different census block tract or at the county level. So the information is really coming from even like as big as the entire countries, and can down to a very single points in the neighborhood layers. And finally, the data will have a different access requirements and limitations. For the smart city data especially, we're going to tap into the open data, but eventually there are a lot of more public data that maintained by different companies, and you may use them, but you may not really redistributing them. There are also like private data, and you may be able to use them, but they don't really they have a very strict requirements on what output can be shared with the public and doing that. So there's a lot of another layers of this project is how we can handle those different access requirements and the sharing the results and based on those data requirements there. So some examples about our active data sources, example including, say, we have data from Austin Open Data Portals and the data we use from census bureaus and the National Weather Services and building with our current use case right now. And we also have some of the smart sensor data that from the company hosted the data as well. So there are mixed the open, public, and the private data already. So I talk about the main challenge about data collection, and the requirements is we need to gather data across those time, space, and the different domains. The challenge maps into the data at different scale, data at different contexts, and at the different schemas. So our goal was to be able to building a more uniform access interface, and that interface unfortunately has to be specific to each of our data sources so it can talk to it. But the idea of that uniform access interface is once we grabbing them, we can map into a uniform structure, then that helps our next step processing to connecting them together. Our next step would be like building a map, a kind of the knowledge map to map those data sources together and for the reuse and for the access of those data. The key here or the goal here is for the access part is we need to implementing different individual data aggregators, and then we mapping them into a general knowledge graph, and through the first year we want to make that as a elastic workflow so we can easily adding a new data sources in and review the result of the graph we're generating, and then be able to piping those data into a web interface so we can know and the people can access what we have been collecting. So one of the examples that we're working on is to accessing the Austin open data portals. If for people who are not familiar with that, it's not just Austin and many of the big cities in the US and even over the country and starting this open data initiative, and they are putting the public data records the city has into a common repository so people can go and search into that. They use one set of tools and the repository tool for access to that data sets specifically, but for our purpose, like for example, for the Austin Open Data Portals, there's close to 5,000 data sets, and they are contributed by different city departments and the different, so they come in a different format like CSV file or just database dump. So we're starting to building a what we call the data accessor is to accessing our data portals, and because it's a uniform API they're using, so the same tools can be used to getting the data from different cities and using the same repository as well. So we can do is we can put in a topic or interest, and we can search by keyword searching through the current one and bring up the set of the data sets that are currently available from there. Then the next step is to be able to go through those metadata and using NLP and trying to help us to connecting them. So ultimately, what we want to do is in this gram is we want to mapping the public data set and then through the NLP extractions and mapping the keyword together and be able to connecting them. And this part has to be a hybrid approach. Like we have some automated work, and then we have experts come to review and trying to build it. And then we can connecting to different use case or prediction models and have the users be able to use the result or accessing the data. So let me just go through one of the current use case example we use to help guiding our development. We're currently collaborating with Austin Fire Departments on the real-time fire incidents impacts prediction and monitoring work. So the goals of here is the Austin Fire Departments, and they have a Twitter account. They can posting here's a new fire emergency or new emergency out there. But they're looking for a better way to be able to monitoring how the active fire events happening. So they're interested specifically on where the smoke can go. Will it go south or go north, and depending on weather, and how that can translate into immediate impact for the local communities as well. So based on the ideas but mapping into this more specific case is we're getting the fire reporting information live from the Austin Fire Department, and we join that with the live weather informations, and we also getting the census data informations and help us to understanding the local communities based on where that happens, and then we can piping that into a smoke spread prediction models. That model can using additional data as well, like air quality sensors or other data sets, and be able to give a better prediction eventually, and then we can using a map viewers and help the fire department and the local communities and to be able to accessing and to be better aware. So I do have a couple of screenshots I have in the slides here, where we have an actual map, and then we can map into what you see here is a live fire, and the arrow here is not really pretty right now, but it's representing the wind directions. So it's an ongoing development. So we actually had more development since I put up the slides there. So, but you can see here when you click one of the fire informations, on the top part is pulling something like the fire department has. In this case, a small grass fire happens in these particular locations. And then we can immediately also join that with the weather information we put from the National Weather Services, getting what's the current conditions and what's the wind direction, and not only the current one, but also what's the next couple of hours. So that can eventually helps us to be able to make the prediction on where the fire, if it's going to or diminishing soon or something. I think I'm actually short on time now. So just quickly about this one is you can see there's a lot of other informations. And for example, the green dots here is actually from different the air quality sensors. We're getting the air quality sensor from two data sources. One is a Polar Air data, and one is a Microsoft Research gave us a couple of sensors, and we can integrating them. Here is really to show the ability to be able to ingest the data not just from one sources and for the same type, but we can put in all the data sources together. It's actually very interesting to the company as well, so they can using different technology trying to collaborating and evaluating theirs. We can also bring the different community data, and here what we show is the fire vulnerabilities, and this is based on assessment on the census data, how many people and what's the condition, what's the type of the census statistics do that estimates and turns to the fire vulnerabilities. And similarly, we can also get in the AFD coverage data, and this one shows what's the typical response rate for the fire department. So it will make sense to the fire people to know this, because if they happen a very well-served area, they can always reach the scene within say 5 minutes. Then it's a less issue than if a fire happens in a remote area. They have a historical byte track record to reach that within, like say, 8 minutes response time for that. That's sort of the use case what we're doing, and the system can do is to bring those different data together and piping those data into the model, and eventually getting those information back. So we want the website not only working for the Austin Fire Department, but it's more important to have to be able to inform the local community who actually being impacted in that cases there. So we're actively working with the fire department on that, on the use cases, and trying to getting more data being ingested into the systems. I guess that's all for my presentations, and thanks for your participation. Or if you have more questions or interest into more project, feel free to visit the Smart City website. I'm putting theirs.
I'm really curious about how you use ML to merge different data sets. Is it heuristics based, or if it's actually data driven, how do we ensure high precision?
So we're currently using a more like a hybrid approach, and we do have a domain scientist and trying to looking for what makes sense. And what for the machine learning side is we're using the existing natural language models and trying to extracting keywords from the metadata from data sets and trying to mapping those data sets across different data sets together. That's our current approach for mapping the data together.
Thank you so much, Weijia.
Yeah.